Hello, welcome to chapter Square and Cube. Now, the story content is Queen Ratna Manjuri left her fortune of Ratna's precious stones, okay, that and create a puzzle in her will. Her son Koinom and 99 relative, that is 100 peoples, were assigned to the participant. Whoever solved the puzzle would inherit the entire fortune. Now, what are the rule of that puzzle? There is 100 lockers in the mansion. Each of the 100 people in the is numbered from 1 to 100. Person 1 opens every locker. Person 2 toggles every second locker. Closes if it is open, opens if it is closed. Third person, every third locker, third, sixth, ninth, and so on. The fourth person toggles every fourth locker, 4, 8, 12th, and so on. This continues until all that 100 gets their turn. In the end, only some lockers remain open. The open lockers reveal the code to the furniture in the safe. Before the process begins, Coinams realized that he already know which locker would be open at the end. How did he figure it out? How he will figure it out, right? The number which is here, every locker is daggled in one of the each person whose number is factor or divisor of the locker number. Example, locker 12 is doggled by the person 1, 2, 3, 4, 5, and 6, 12th, which is 6 time. If the locker is doggled at even number of times, if it ends up closed. If doggled an odd number of times, it ends up open. The important note is the number has an odd number of factor only if it is perfect square, because if the factor repeats like 6 into 6. Therefore, only lockers with the perfect square numbers 1, 4, 9, 16 up to 100 remains open at the end. The open lockers are 1, 4, 9, 16, 25, 36, 49, 64, 81. That that's that is 10 lockers in total. Next, if a locker is toggled on an odd number, it will be open. Otherwise, it will be closed. The number of times a locker is toggled is same as the number of factors of loggle, locker number. For example, for locker 6, person 1 open it, person 2 close it, person 3 open it, the person 6 close it. The number 1, 2, 3 and 6 are the factor of 6. If the number of factor is even, the locker will be toggled by an even number of people and it will be eventually closed. Note that each factor of number has the partner factor so that the product of their factors yield the given number. Here 1 and 6 form the pair of factors of 6. 2 and 3 forms another pair. Thus, every number has an even number of factors 1. 1 into 1, the only factor is 1. 4, 1 into 4, 2 into 4. Here the factors are 1, 2, 4. Here for 9, 1 into 9 and 3 into 9. The factors are 1, 3 and 9. We see in some cases like 2 into 2 that the number in the pair are same. Can you use this insight to find more numbers with an odd number of factor? For instance, 36 have the factor pair 6 is to 6, where both numbers are 6. Does this number has an odd number factor if every factor of 36 other than 6 has a different factor as its partner? Then we can sure that 36 has an odd number of factor. Check if this is true. Hence, all the following has an odd number of factors. 1 into 1 is to 1, 2 is to 2, 3 is to 3, 4 is to 4. The number that can expressed as the product of the number with itself is called square number or simply square. The only number that has odd number of factors are the squares because they each have one factor when multiplied by itself equal the number. Therefore, every locker whose number is square will be remain open. This is the main point. Write the locker number that remain open. Coinum immediately collects the word clue from these 10 lockers and read the passcode consists of first 5 locker numbers that were touched exactly twice. Which are these 5 lockers? The lockers that are toggled twice are prime numbers. Since each prime number is as 1, the number itself as a factor. The code is 2, 3, 5, 7, 11. Square numbers. Why the numbers 1, 4, 9, 16 called squares? We know that the number units squares in the square. The area of square is the product of its side. The table below give the area of square with different sides. Side length in the unit and area in square unit 1, which is 1 into 1, which is 1 square unit, 2 into 2, which is 4 square unit, 3 into 3, which is 3 square 9 square unit. Next 4 into 4, which is 16 square unit, and 5 into 5, which is 25 square unit, 10 into 10, which is 100 square unit. We use the following notation for the squares. 1 into 1, which is 1 power 2 is equal to 1, which is happening for 2, 3, 4, 5. In general, for any number n, we write n into n is equal to n square, which is read as n squared. Can we have the square of side length 3 by 5 or 2 by 5 units? Yes, there are square area in square units are 3 by 5 square, which is 3 divided by 5 into 3 divided by 5, which is 3 into 3, which is 9, and 5 into 5, which is 25, which is 9 by 25. And 2.5 square, which is equal to 2.5 into 2.5, which is equal to 6.25. The squares of natural numbers are called perfect squares. For example, 1, 4, 9, 16, 25 are all perfect squares. Patterns and the properties of perfect square. Here, find the squares of the first 30 natural numbers and fill the table. Let us fill the table. Already here filled 1 square is equal to 1, 2 square, which is 2 into 2 is 4, 3 into 3, which is 9, 4 into 4 is equal to 16, 5 into 5, which is 25, 6 square, which is 36, 7 square, which is 49, 8 square is equal to 64, and 9 square, which is 81, 10 square is equal to 100. 11 square is equal to 121, 12 square is equal to 144, 13 square is equal to 169, and 14 square, which is equal to 196, and 15 square, which is equal to 225, 16 square is equal to 256, and 17 square is equal to 289, 18 square is equal to 324, 19 square is equal to 361, 20 square, which is equal to 400, and 21 square is equal to 441, 22 square, which is equal to 484. Next, 23 square is equal to 23 into 23, which is equal to 529. I cannot use the symbol of power, so I am using as 20. I am taking this symbol as square. Okay, 24 square is equal to 576, and 25 square is equal to 625. 26 square is equal to 676, and 27 square is equal to 729, and 28 square is equal to 784. 29 square is equal to 784. 41. Next 30 square which is equal to 900. Now, what pattern do you notice? Share your observation, make the conjunes. Study the squares in the table above. We have to study that. What are the digits in the unit place of these numbers are? That's are all these numbers end with 0, 1, 4, 5, 6 or 9. None of them end with 2, 3, 7 or 8. If a number ends with 1, 0, 1, 4, 5, 6 or 9, is it all a square? Now, the number 16 and 36 are both square with 6 in the unit place. However, 26, whose unit is also 6, is not a square. Therefore, we cannot determine if the number is a square just by looking at the digit within the unit place. But the unit digit can tell us whether the number is not a square. If the number ends with 2, 3, 7 or 8, then we definitely say that it is not a square. Write 5 numbers such that you can determine by looking at their unit digit that they are not squares. The squares are 1, 1 square, 9 square, 11 square, 19 square, 21 square, 29 square. All have 1 in their unit place. Write the next 2 squares. Notice that if a number has 1 or 9 in the unit place, then it is square end in 1. Okay, let us consider the square number ending in 6, which is 16 is equal to 4 square, 36 is equal to 6 square, 196 is equal to 14 square, 256 is equal to 16 square, and 567 is equal to 24 square, and 676 is equal to 26 square. Which of the following numbers have the digit 6 in the unit place? Let us calculate that. First one, 36 square, which is 36 square is equal to 38 square, which is equal to 1444. Next, 34 square, which is equal to 1156, which is unit digit is 6. Next, 46 square, which is equal to 2116, which unit digit is equal to 6. Next, 56 square, which is equal to 3136, which is unit digit equal to 6. And 74 square, which is equal to 5472, which units digits is 6. Next, 82 square. 82 square is equal to 6724. Here, find more such pattern by observing the number and the scores from the table you filled earlier. Consider the following numbers. Here 10 square, 20 square, 40 square. We have 1 zeros, but we have 2 zeros. Here 100 square, 200 square. Here we have 2 zeros. Here we have 4 zeros. For this we have squares always end 0, 1, 4, 5, 6 and 9. Even number square is equal to, while we are even number square is equal to even, and odd number square is equal to odd. Next, difference between the square of consecutive numbers is equal to odd number. Between n square and n plus 2 square is equal to 2n numbers. Sum of first n odd numbers is equal to n square. These are the following numbers. Okay. If any number contains 3 zeros at the end, how many zeros will it square have at the end? Let us take the example of 1000. While squaring it, we have another 30, which is equal to 60. Squaring a number doubles in the number of trailing zeros. Okay. Next, what do you notice about the number of zeros at the end and number of zeros at the end of its square? Will this always happen? Can we say that the square can only have a even number of zeros at the end? Here, yes. The answer is yes, because the number of trailing zeros in a square is always even. Squaring always have even number of trailing zeros. Example explanation: each zero at the end means factor of 10, which is 2 is to 5. When squared, each 2 is to 5 become 2 of each more zeros. So if the number ends in the square of zeros, example 3, square ends in even, example 6. Here answer is yes, the number of trailing zeros in a square is always even. Squares always have even number of trailing zeros. Next, what can you say about the party of a number and its square, which is odd number is odd square, even number is even square, perfect square and odd numbers. Let us explore the difference between the consecutive squares. What do you notice? 4 is to 1 is equal to 3, 9 minus 4 which is 5, 16 minus 9 which is 7 and 25 minus 6. You see, if this pattern continues for few squares numbers, from this we can observe that adding consecutive odd numbers starting from 1 gives consecutive square numbers as below. 1 is equal to 1, 1 plus 3 which is 4, and 1 plus 3 plus 5 which is 9, 1 plus 3 plus 5 plus 7 which gives 16, 1 plus 3 plus 5 plus 7 plus 9 which gives 25, and 1 plus 3 plus 5 plus 7 plus 9 plus 11 which gives 36. Do you remember this pattern from grade 6? The picture below why each subsequent inverted L gives the next odd number. Here 1 plus 1 which is 4, next to 1 plus 3 plus 3 plus 2, 1 plus 3 plus 5, like that. We see the sum of the first n order number is n square. Alternatively, every square is a sum of successive odd numbers starting from 1. Also, we can find out whether the number is perfect by successively subtracting odd numbers. Consider the number 25, successively subtracting 1, 3, 5 until you get or crossover 0. 25 minus 1 which is 24, 24 minus 3 which is equal to 21, 21 minus 5 which is 16, 16 minus 7 which is equal to 9, 9 minus 9 is equal to 0. This means 25 is equal to 1 plus 3 plus 5 plus 7 plus 9 and is thus a perfect square. Since we subtracted the first 5 odd numbers, 25 is equal to 5 square. Using the pattern above, find 36 square given the 35 square is equal to 1225. From the question we know that 1225 is the sum of first 35 odd number. To find 36 square, we need to add the 36th odd number is 2225. How do we find the 36th odd number? The first odd number is 1 and the second odd number is 3, third odd number is 5 and the sixth odd number is 11 and so on. What is the nth odd number? The nth odd number is equal to 2n minus 1. Therefore, the 36th odd number is 71. By adding 71 to 1225, we get 1296, which is 36 square. Consider the number such as 36 that is not a square. Subtract the consecutive odd number starting from 1. 38 minus 1, which is equal to 37. 37 minus 3, which is equal to 34. 34 minus 5, which is equal to 29. 29 minus 7, which is equal to 22. 22 minus 9, which is equal to 13. 13 minus 1, 11, which is equal to 2. And 2 minus 13 is equal to minus 11. This shows that 38 cannot be expressed as a sum of consecutive odd numbers starting with 1. Thus, we can say that the natural number is not a perfect square if it is cannot be expressed as a sum of successive odd natural numbers starting from 1. We can use this result to find out whether the natural number is perfect square. Find how many numbers lies between two consecutive perfect squares. Do you notice a pattern? Here, between 1 square, which is equal to 1, and 2 square is equal to 4, two numbers 2, 3. Between 2 square, there is equal to 4, and 3 square is equal to 9. 4 numbers is equal to 5, 6, 7, 8. Between 3 square is equal to 9, and 4 square is equal to 16. 6 numbers 10, 11, 12, 13, 14, 15. So the pattern is there are 2n numbers between n square and n plus 1 square. Next, how many square numbers are there between 1 and 100? How many are there? 101 and 200. Using the table of square you filled earlier, enter the values below, tabulating the number of squares in each block of 100. What is the largest square less than 1000? Now let us calculate that. From this 1 to 100, the range will be 1 square to 10 square, which is equal to, count is 10 here. Next, 101 to 200, where is 121, 144, 169, 196, which is 4 count. And from 201 to 300, there is 31, 225, 256, 289, which is the count of 3. Next, 300 to 400, which is 324, 361, 400, which is equal to 3. Next, 400 to 500, which is equal to 441 and 484, which is equal to 2. 501 to 600, which is equal to 529, 576 is 2. And 601 to 700 is equal to in between 625 and 676, which is equal to 2. Next, 701 to 800, which is equal to 729, 784, which is equal to the count of 2. 801 to 900, which is equal to 841, 900, which is count of 2. And 900 to 1000, which is 961, the count is 1. 31 square is equal to 961. 32 square is equal to 1024, which is too big. Square less than 1000 is 961. The answer is 961. The perfect squares and the triangular numbers. Do you remember the triangle numbers 1, 3, 6, 10 and 15? Okay, can you see any relationship between triangular numbers and square numbers? Extend the pattern shown and drawn the next term. Here 1 plus 3 is equal to 4, 2 square. Here 3 plus 6 is equal to 9, 3 square. Which is 6 plus 10 is equal to 16 square. 16, which is equal to 4 square. Here the next pattern is 10 plus 15 is equal to 25, which is 5 square. We can provide here 25 dots. Square roots. The area of the square is equal to 49 centimeter square. What is the length of its side? We know that 7 into 7 is 49. 7 square is equal to 49. So the length of the side of the square with the area of 49 centimeter square is equal to 7 centimeter. We call 7 the square root of 49. In general, if y is equal to x square, then the x is the square root of y. What is the square root of 64? We know that 8 into 8 is 64. See, 8 is the square root of 64. Now, minus 8 into minus 8, which is equal to 64 square. The square root of 64 are plus 8 and minus 8. Each perfect square has two integral square roots. One is positive and another is negative. The square root of the number is denoted by this symbol. Square root of 64 is equal to plus or minus 8 and square root of 100 is equal to plus or minus 10. Note that square root of 8 square, which is equal to plus or minus 8, and square root of 10 square is equal to 10 plus or minus 10. In general, square root of n square is equal to plus or minus n. In this chapter, we shall only consider the positive square roots. Given a number such as 576 and 324, how do we find out if it is a perfect square? If it is a perfect square, how can we find its square? We know that this perfect square end in 1, 4, 9, 6, 5 or an even number of zeros. But it is not certain that the number that satisfies this condition is square. We can clearly say 327 is not a perfect square. However, we cannot be sure that 576 is a perfect square. We can list all the square numbers in the sequence and find out whether 576 occurs among them. We know that 202 is equal to 400. We can find square of 221 is 22, 23. So until we can get 576. Here 20 square or a number greater than 576. 20 square is equal to 400. 21 square is equal to 441. 22 square is equal to 484. 23 square is equal to 529. And 24 square is equal to 576. However, this process becomes insufficient for large number. It is hard for large numbers. Remember, recall that every square can be expressed as a sum of consecutive odd numbers starting from 1. Consider square root of 81. 81 minus 1 is 80. 81 minus 3 is equal to 77. 77 minus 5. Then getting answer, subtracting it from 7, 9, next 11, 13, 15 until 17, which is 0. From 81, we successfully subtracted consecutive odd numbers starting from 1 until we obtained it 0 at the ninth step. Therefore, square root of 81 is equal to 9. Can we find the square root of 729 using this method? Yes, but it will be time consuming. We know that perfect square is obtained by multiplying an integral by itself. We look at the number prime factorization help in determining whether it is perfect square. Yes, if we divide the prime factors of the number into two equal groups, then the product of the prime factors in either group combine to form a square root. Is 324 is a perfect square? Let us check that. 324 is equal to 2 into 2 in 3 into 3 and 3 into 3. These can be grouped as 2 into 3 into 3 and 2 into 3 into 3. 2 into 3 into 3 square is equal to 18 square. We can also return the prime factors in the pair that 224 is equal to 2 into 2 and 3 into 3 and 3 into 3, which shows that 324 is a perfect square number. Thus, 324 is equal to 2 into 3 into 3 whole square is equal to 18 square. This is a perfect square. Is 156 a perfect square? The prime factorization of 156 is 2 into 2 into 3 into 13. We cannot pair up these factors. Therefore, 156 is not a perfect square. Find whether 1156 and 2800 as perfect square using the prime factorization. We can estimate the square root of large perfect square by looking at the closest perfect square we are familiar with and narrowing down to the interval to space. For example, to find square root of 1936, we can reason as follows. 1936 is between 1640 square and 2550 square. So 40 lesser than square root of 1936 lesser than 50. The last digit 9 1936 is 6. So the last digit of the square root must either be 4 or 6. It can be 44 or 46. If we calculate 45 square, we can compare it with 936 to have the interval to search from 40 to 50. Either 40 to 45 or 45 to 50. We can write 45 square is equal to 40 plus 5 and 40 plus 5, which is equal to 40 square plus 2 into 40 into 5 and 5 square, which is equal to 1600 plus 400 plus 25, which is equal to 2025. 2025 is greater than 936. So 40 lesser than square root of 1936 lesser than 45. From the observation in the point, we can guess and verify 936 is 44.